Okay, this is section 5.5, page 1. First thing we have is a theorem. It's called the 45-40-90 theorem. And that's because we're in a triangle whose angles measure 45, 45, 90. And so it's telling us that the hypotenuse has a length equal to the product of the square root of 2 and the length of either leg. So if this leg is A, then the hypotenuse would be A square root 2. So let's go ahead and write that down. The leg is equal to A, and the hypotenuse is equal to A square root 2. So those are sort of like our formulas. Not sort of like, they are. Okay? So now we want to prove it. So we're going to just start off with a 45, 45, 90 triangle. And we're going to show that we have that relationship. Okay? So here's our right triangle, 45, 45, 90. So because we're in a right triangle, we know we can use the Pythagorean theorem. So let's use, let's say since. Since we have a right triangle, use Pythagorean theorem. Okay, so that says a squared plus b squared equals c squared. Okay, we don't have any sides here at all. Let's go ahead and label this A. All right? Well, what do we know? If that side is A, what do we know about this side? Well, if you remember, if you have this base angles the same, then what can we say about the sides opposite them? They're also the same. So if this side is A, this side has to be A. Remember, we're in an isosceles triangle. If you want to flip it around and say those are the base angles, they're congruent, which means the sides have to be congruent. So we know both sides are A. So instead of saying A squared plus B squared, we want to say A squared plus A squared. They're both measure A squared. And then we're going to solve for C and see what this side ends up being. So when we have A squared plus A squared, that's 2 of those. So 2A squared equals C squared. And remember, we're solving for C. So we're going to take the square root of both sides, putting in a plus and minus. And we get C over here. Over here we get plus and minus square root of 2. We're going to break this up. And the square root of A squared. Okay, because we're talking about a triangle, length can't be negative, so drop that out. Then we're going to say just the square root of 2 here, and then just square root of A squared is A. Now, because it's a little confusing, does the square root cover the A or not? Typically, the way people write this is they say C equals A and then the square root of 2. So the square root goes at the back. So that's what we're going to do too. So now, if we look at this, what do you know? That's exactly what we said. The hypotenuse was A square root of 2. It's A square root of 2 here. So that's our proof of it. So let's move on now to an example where we use this. We're given a right triangle, XYZ. So we have XYZ. And X measures 45, so let's go ahead and put that on there. Okay, and then also we know that XY is 12 square root 2. So XY is 12 square root 2. Okay, if this angle is 45 degrees, what's that angle? If this is 90, these two have to be 90. So that would be 45 also. Okay, we're supposed to find XZ and YZ. XZ and YZ, so the other two sides. Well, if we're in a 45, 45, 90, we have some rules. So let's say triangle XYZ is a 45, 45, 90 triangle. Okay, so then that tells us we have some rules. We know that this side is A, this side is A, and this side is A square root 2. That's what the formula says. Take a look. It says the legs are A, so A and A. Hypotenuse is A square root 2. So now look, we have a relationship. We know if this is A square root of 2 and this side is 12 square root of 2, we can just kind of see what A has to be. But let's go ahead and write a formula. So we know that the hypotenuse has to equal A square root 2. That we're getting from here. And then in our particular case, we know that it measures 12 square root of 2. So we're going to write 12 square root of 2 equals a square root of 2. So we're trying to solve for a. That's what we want to know. What is a? So we're going to divide both sides by the square root of 2. And then what happens here? Well, drops out here, here, and here. So what are we left with? We're just left with a is 12. Okay? So now that's what the lengths are. That's what the sides are. So remember that the leg equals a. So that means that xz is equal to a, or xz is equal to 12 in this case. So let's go ahead and circle that. That's what they wanted to know. So again, leg equals a, and yz is also a leg, so it equals a. So that means that yz is 12. Okay? So once we find that a is 12, then we can just plug it in here and there, and that's what we did. Okay? On to the next problem. Number 6. Okay, so in this one we have a right triangle, XYZ. XYZ is a right triangle. And we're told that XZ, right here, is congruent to YZ, right there. And we're also told that XY is 10. Okay? We're supposed to find both XZ and YZ, so the other two sides of the triangle. Okay, when we look at this, what do we know? We have a right angle, and we know that this is an isosceles triangle, right? These two sides are congruent, which means these two angles must be congruent. And all we have is 90 degrees for those two, so each one would have to be 45. So let's go ahead and put that in. And once we know that, then we can say that triangle XYZ is a 45, 45, 90 triangle. Okay, so now let's put the formulas in. We know, let's pull it down here. What are our formulas? Legs are equal to a, hypotenuse a square root of 2. So let's go back up here. So these sides are a, this side is a square root 2. So this is where our equation is going to come from. So let's write it down. We know that the hypotenuse is equal to, by formula, a square root 2. Our particular hypotenuse is equal to 10. So let's go ahead and put a 10 in there. So hypotenuse is 10. Okay, so we're trying to solve for a here. So what do I need to get rid of? I need to get rid of the square root of 2. So we're going to go like this, get rid of the square root of 2, divide both sides. And our answer is that a, they cancel out here, is equal to 10 over the square root of 2. Okay, so that is the answer if you're not comfortable with radicals. So I'm going to go ahead and circle it because I would accept that. I know not all of you know your radicals real well. So if we go on though, if you know your radicals, so if you know radicals, you can keep going, and this will help you prepare for next semester. Let's keep going with this. Let's say that a is equal to 10 over the square root of 2. So I just switched it around here. So we cannot leave a radical in the denominator. That's one of the rules of being in simplest radical form. So the way we get rid of that radical in the denominator is we multiply it both top and bottom, which of course that's just 1. Okay? So what would happen then? Well, we get 10 square root 2 in the numerator. In the denominator, we would get square root of 2 times square root of 2, which we can combine that into 1 and get the square root of 4 by multiplying 2 times 2. Well, then that simplifies into 10 square root of 2 over, what's the square root of 4? 2. So now we can go ahead. We cannot simplify these two because one's under the radical and one isn't. But we can simplify those two. So we're going to go ahead and say 2 goes into 2 once, 2 goes into 10 5 times. So the final answer in simplest radical form would be 5 square root 2. Okay, so here I would accept either one. Okay, are we done? No, we are not. It asks us to find xz and yz. Well, those are a, so we're just about there. So let's go ahead and write that a leg, the formula for a leg is that it's equal to A. And so what is a leg? Our xz is a leg, and it's equal to A. So in our case, A is 5 square root of 2. So that's what we get. Again, the other leg is equal to A, so we get zy is equal to A, and zy would be equal to, what's A? 5 square root 2. So now we've answered both questions, and that completes page 1 of section 5.5. Go on to page 2.